In this homework video guide, I will be continuing the problems on section 2.3, starting with question number 5a. And for the questions in number 5, I still need to factor, and I am factoring by using the greatest common factoring technique. So for question 5a, I do have two terms, one in blue and one in red. And if you look at those two terms, you should notice that both of them have a common factor of 2x plus 1. All right, so when you have a common factor, you can pull that out. So I'll pull out the 2x plus 1 to the side. So basically, this 2x plus 1 and that 2x plus 1, I'm pulling them out. And then ask yourself what is left. Well, there's an x here and a plus 3. So the x plus 3 is what remains. So your final answer is 2x plus 1 times x plus 3. Let's move on to letter B. And for letter B, once again, we have two terms, one in red and one in blue. And you should also notice that there's an invisible 1 here, which I'll highlight in a light blue. And then ask yourself, in both those terms, is there a common factor? And the answer is yes. It's x plus 1 and x plus 1. So how do you factor out the x plus 1? Well, you can pull it to the side. And then ask yourself, so I'm pulling out the x plus 1 to the side. And then ask yourself what is left over. Well, there's an x here and a plus 1. So in brackets, I can write down x plus 1. So my final answer is x plus 1 times x plus 1. Okay, let's move on to letter C. And for letter C, you should notice that there's a 3y plus 1 here and a 3y plus 1 there. So we're going to factor that out. So I will write 3y plus 1 over here and ask yourself what is left over. Well, the 3y and the negative 2, that is what's left over. So let's write 3y minus 2, and then you're done your factoring. All right, let's continue on and finish up all the odd letters here. So for letter E, there's a plus 2b and a plus 2b. If I factor that out, that'll be a plus 2b. And then what remains, I have an a and a plus b. So I can write that as a plus b. And that is my final answer. For letter G, I have 5f minus 1, so let's go ahead and factor that out. So 5f minus 1, and then let's ask ourselves what is left over. Well, it's the 3e and then the minus 7. So there's my final answer there. Now letter I, we have to do a little bit of work with letter I because you'll notice that there's an x plus 1 here, but I have a 1 minus x over here. So they're not exactly the same. So I do have to do a little bit of algebra to make sure that there is a common factor here. So let me just start off by copying out the first part. That part remains the same, and then the minus 3 will remain the same. Now this part here in red, I'm going to do two moves here. So the first move is I'm going to flip the order. All right, so if I have a plus b, that's the same thing as b plus a. So that's what I mean by flip the order. And then after I flip the order, one thing that we will be working on throughout this chapter is we're going to factor out that minus sign. So if I factor out the minus sign, now I'll get x minus 1. All right, so, and fortunately this negative 3 here is still hanging around, and I still have this x times x minus 1. Okay, so I'm factoring out this minus sign. Now, if you actually distribute the minus sign through again, you'll get negative x plus 1, which is exactly what we have over there. So we have technically factored out the minus sign correctly. Okay, now one thing after you do that, one second, kind of, let me go back here, erase this. Okay, so once I've done that, you'll notice that, I'm just going to erase this here. Oops. Making a little bit worse than it already is. Okay, so there's a minus sign here in green, but there's also a minus sign over there. So if I consider these two minus signs, it's like negative 3 times like a negative 1. So a negative 3 times like a negative 1 gives you positive 3. So I'm going to erase all this, and I'm going to write positive 3. Okay, so there you go. Now you can notice that the x minus 1 and the x minus 1, they're exactly the same. So in order to make those two factors to look the same, you have to rearrange the 1 minus x and factor out a minus sign. Okay, so let's go ahead and pull out the x minus 1 now, and then this x and that plus 3 remains, so it's x minus 1 plus 3. Okay, before I move on to the next question, let me kind of redo this question one more time, just because when the first time you see it, it does take a little bit of time to kind of get used to the problem. So as I was saying that these two terms are not the same, so what you want to do is you want to rearrange this term right here. You start up by writing this as negative x plus 1, and then everything remains the same. And then over here, let's just move this to the side here. If you factor out this minus sign, you get negative bracket x minus 1. Now you have to realize that this is the same thing as negative x plus 1. Those two expressions are exactly the same, and if you distribute this minus sign, you'll see that it is, so negative x plus 1, which is exactly the same thing as that, which is basically this thing over there. Okay, so your goal is you really want to be able to write this expression here like that. And the reason why you want to do that is because I have an x minus 1 here, and I also have another x minus 1 there in green. Okay, so that's why we want to rearrange the terms and factor out the minus sign. The last thing that may have not been so clear is that we have a minus sign here, and we also have a negative 3 here. Okay, so if I multiply those together, negative 3 times that minus sign gives you positive 3. And then this thing can remain there as x minus 1, and then I have an x and then x minus 1. And now you can see, after doing all that work, these two terms are the same, and now you can factor that out as x minus 1, and then this x and that plus 3 remains, so I have an x plus 3. All right, so if you weren't so comfortable with that, don't worry, we will practice a few more of those in class. Okay, let's move on to question number 6 now. So these kind of problems we usually assign towards the end of the chapter, and you'll notice that for these kind of problems, there's 4 terms. All right, so when you have 4 terms, we want to factor this by grouping. And you'll notice that a lot of the techniques that we used in question number 5 will come up again in question number 6. So this is how you would factor this by grouping. Since you have 4 terms, 1, 2, 3, 4, you're going to split up the terms into groups. So let me put a vertical line straight down here. So now you have 2 terms on each side of that red line. Okay, from there on, take a look at the x squared and the xy. What's the common factor that you can pull out? Well, both of these terms have an x. This one has 2 x's and this has 1 x. So what's the maximum number of x's that you can remove? Remember, you always take out the number of x's with the lowest power, which is 1 in this case. So let's factor out an x. If I do that, I get an x plus y. Okay, so once again, if I take a look at x squared and xy, you need to factor out the common factor, which is this red x there, and then you get x plus y. If you want to do a quick little check if you did this correctly, just distribute. X times x is x squared, and x times y is plus xy, which does indeed match that. Okay, so we'll leave this as x times x plus y. Now over here on the green side, the question is, what can you factor out of there? Well, there's a plus 2 and a plus 2, so I can definitely factor out a positive 2. So if I factor out a positive 2 out of here, I get x plus y. And now you'll notice that now we're back to a question similar to the problems that you saw in question number 5. Whereas x plus y and x plus y, they're common, so you can pull that out as an x plus y. And ask yourself what is left over once you pull those out. Well, there's an x here and a plus 2, so x plus 2. Just tag that along, and that's your final answer, x plus y times x plus 2. Okay, let's move on to letter B. Once again, I have 4 terms, 1, 2, 3, 4. If that's the case, put a vertical line right down the middle so that you have 2 terms on each side. On the left-hand side, I have 2 a's and 1 a, so there's a common term of a in both cases there. So we always pull out the a that has the smallest power there. So let's pull out one of them. So now I have an a plus a b. And over here on the right hand side, there's a negative 2 and a negative 2. So let's go ahead and factor out a negative 2. If I do that, I get a plus b. All right, and once again, if you're not sure if you did this step correctly or not, just distribute. Negative 2 times a is negative 2a, and negative 2 times b is negative 2b, and that definitely matches up with that expression. Okay, now as you can see, a plus b and a plus b are the same, so let's factor out the a plus b, and what's left over, I have an a and a negative 2a, so this will be a minus 2, and that's your final answer. Okay, let's move on to letter C here. Once again, for letter C, I have 4 terms. Let's put a vertical line right down the middle. And if I take a look at the left-hand side, I can factor out a 6y. If I factor out 6y, I get a y plus 2. And then on the right-hand side, I have a negative 3y and a negative 6. So if I look at the negative 3 and the negative 6, I can factor out a negative 3. And if I do that, I get y plus 2. Okay, and once again, if you're not sure if you did the factoring correctly, just kind of distribute. You get negative 3y, and negative 3 times 2 is negative 6, and that indeed matches the green expression there. Okay, and just like all the problems that we have approached so far, you'll notice that we do have a common factor there. So let's pull it out to the side as y plus 2. So those things are done. And then what's left over, I have a 6y and a negative 3, so bracket 6y minus 3, and that's your final answer. Okay, let's move on to letter F now. Once again, we have 4 terms, so let me just kind of pull out or put a vertical line down there. Over here, 1 plus b, I really can't factor anything out. The only thing I can factor out is a 1. If I factor out a 1, I just have 1 plus b here. And over here on the right-hand side, there's a minus sign and a minus sign. And then both of them have an a, so I can factor out a negative a. If I do that, I get 1 plus b. And once again, if you're not sure if you did that correctly or not, just distribute through. Negative a times 1 is negative a, and negative a times b is negative ab, and that indeed matches that. Okay, so once you've done that, notice that there's a 1 plus b and a 1 plus b, so I can factor that out as 1 plus b. So those guys cancel off, and what's left over, there's a 1 and a negative a, so 1 minus a. And there you go, that's how you factor those kind of problems on question number 6. Okay, let's take a look at a few more visual questions here, and kind of like some word problems, and then we'll finish off this homework video guide. All right, so question number 7, determine the shaded region area. Sure, determine the shaded area in factored form if the circles are each of radius r. Okay, so the circles have a radius of r. All right, so what does that mean? Here's my first circle, that's a radius of r. And that means over here, that's a radius of r. So if I look at the total distance, I'll use a black marker here. If I go straight across, that's going to be 2r. Okay, so this whole distance here is 2 radii, so it would be 2r, and that will also be 2r. Okay, and then if you look at this entire distance here, 2r plus 2r is going to be 4r. And then if I look at this distance right here, that's going to be 4r. Okay. All right, so now we have the area of the square. If you think about the area of the square, that's simply going to be, 4r times 4r, which is going to be 16r squared. So that's the area of the square there. And inside the square, we have 4 circles, right? So what I'm thinking here is if we calculate the area of one of these circles, then we can times it by 4 because we have 4 of these circles, and then we can just subtract the 2 areas to find that shaded region. So what's the area of one of those circles? So what's the area of one of these circles? Because I'm going to subtract these, right? Well, the area of a circle is pi r squared. All right, so minus pi r squared. But what is the radius? What is the radius here? Well, the radius is well, it's just r, right? Right, the radius is r, and how many of those circles do you have? Well, you have 4 of them. You have 4 of those circles. All right, so if you find the area of the square minus the 4 circles, then you have the shaded region. All right, let's go ahead and simplify this now. So the area of the square is 16r squared minus 4 pi r squared. Okay, so this r to the power 2 is just r squared. Okay, now take a look at this expression here. What can you factor out that's common? Well, both of them have an r squared, right? So we can pull out an r squared. Both of them have a factor of 4. There's a 16 and there's a 4 there, so I can pull out a 4. So if I pull out a 4r squared, what is left over? Well, I get 4 minus pi. And if you're not sure if that's correct or not, just distribute to check. 4r squared times 4 is 16r squared, and 4r times pi is minus 4 pi r squared, and this definitely matches that expression right there. And that's how you do question number 7. And the last question for this homework video guide is question number 10. Determine the shaded area in factored form. So I guess this yellow region is the shaded region. It will probably be a little bit more clear in your workbooks. All right, so I've got to find that shaded region, and basically all you're doing is you're finding the area of the big circle. So when I'm talking about the big circle, I mean this whole entire thing. Let's just assume this whole big circle is completely filled up, and its radius is r plus 2, so the big radius is r plus 2. And then you also have a small circle, right? Which is this piece right there, right? So the small circle I will draw out like that, and its radius is just r. All right, so you're going to find the area of the big circle, and then you're going to subtract the area of the small circle, and that should give you the area like between the two circles, which is represented by this yellow region right here. Okay. All right, so if you're finding the area of a circle, the general formula is pi r squared minus pi r squared. Now for the big circle, the radius is going to be r plus 2. So we'll plug that in for this r. So pi bracket r plus 2 to the power of 2 minus pi times, well, this r is that r, so the r's just stay the same, and that's what we have. In order to kind of simplify this, let's go ahead and deal with this yellow expression right here. We can use the square double square technique. So that'll be r squared plus 4r plus 4 minus pi r squared. Okay, so we're just using the square double square technique. And after that, we can distribute here. So that'll be pi r squared plus 4 pi r, and pi times 4 is 4 pi. And then we have this minus pi r squared. And you'll notice that these terms right here cancel off. And you're left with 4 pi r plus 4 pi. And let me just kind of rewrite that again. So this is going to be 4 pi r plus 4 pi. And then from here, what can you factor out? Both of them have a 4 pi, right? So you can factor out a 4 pi. And you're left with r plus 1. And once again, just distribute if you're not sure. 4 pi times r is 4 pi r, and 4 pi times 1 is 4 pi, so that's correct. All right, so that concludes this homework video guide for section 2.3.